So, welcome students. Today we will look into the numericals of radial engines, balancing of the radial engines. So, in the previous lecture, what we had seen is what do we mean by radial engines and the concept of direct and reverse cranks for primary as well as secondary engines for radial engines. So, today we'll start looking at the numericals. So, this is a numerical. In this numerical, I will read out the numerical first. So the problem is given in a word statement. You need to form a diagrammatic view of that particular diagram, like whatever data is given, and then we need to proceed with solving the numerical. So let's look at the question first. So in the question, what they have mentioned is the three cylinders of an air compressors have their axis at 120 degrees to one another. Now, what does this mean is, okay, this is engine number one, or maybe like I am talking about engine, but it is air compressor. So the piston of compressor number one is in this vertical direction. So the line of stroke is in this direction. The second is this one. So the line of stroke of this particular compressor is in this direction. So first, second, the angle between these two is 120 degrees. And the third, so for the third, the compressor is this, the piston is at position number 3. And the line of stroke between this is this particular green line. So the angle between this is 120. So the angle between 1 and 2 is 120. Between 2 and 3 is 120. Between 3 and 1 is 120. So that is what is given in this data. And the connecting rods are coupled to a single crank. So this is a radial engine. It is coupled to a single crank over here. The stroke is 100 mm. So what they have given is stroke. Stroke is equal to 100 mm. So based on the stroke, we can find the radius of crank. That is nothing but stroke divided by 2, which is equal to 50 mm. So this data is given from this particular thing. The length of the connecting rod. So L is given. How much is L? L is 150 mm. So once we get L and R, what we need to find is N. N is equal to L by R, which is equal to 150 divided by 50. That would be 3. Next data is the weight of reciprocating parts per cylinder is 15 Newton. So they have given mass M is equal to 15 Newton per cylinder. Now they have given this data in terms of Newton, but what we require is in kg. So 15 divided by g, which is equal to 15 divided by 9.81. So that M comes out to be 1.5291 kg per cylinder. So this data is again given to find. So he has asked to find. What is required to be found is maximum primary and secondary forces acting on the frame of the compressor. So they need to find FP and FS. We already have talked that primary couple and secondary couple are balanced since this engine is rotating in a single plane. So out of plane, no forces, so no couple. Nextly, what they have given, it is running at 3000 RPM. So he has given speed N is equal to 3000 RPM. So based on this data, what we can find is omega. Omega is equal to 2 into pi into N upon 60. So after fulfilling the data, you get it to be 314. This value is 314.159 radian per second. So this data is given, this mass is given, this N is equal to L by R is given. And this entire diagram is given. So next what we need to do is we need to look at this data and solve the numerical problem. So first and foremost thing what we need to do is we need to find the angles. So for that angles what we need to do is we need to look at this one and prepare this table. So this is the solution. This is step number 1. Step number 1. So we need to have angle for primary. So one is direct, another is reverse. So this is for primary, this is for direct, reverse. Secondary, direct and reverse. So we need to have this different data. This angle is nothing but the position. Angle is nothing but the positions. So this is the data that we are going to have from this one. So if you look at this particular data, okay, what we need to do is, first I will put at first one. Now for the first one, let's assume this to be your original position. So I assume this to be at 0 degrees. So direct would be at 0 degrees. The angle of direct is 0 degrees. We know reverse would be 0 degrees. Okay, that we had already seen in the previous lecture. So if the direct is theta, reverse would be minus theta. So minus of 0 is 0 degrees. For secondary, we know this is for primary. If this angle is for primary, then for secondary, the angles are written as this is 2 theta and this would be minus 2 theta. This is for direct, this is for reverse. So 2 times of theta is 0 degrees again, reverse for 0 degrees again. So this fulfills this one. You need to use this particular concept, what we had already discussed in previous lecture. So 0, negative 0, that will be 0. 2 times of 0 is 0. Reverse 2 times of negative 0. Negative times of 0 is 0 again. Next, coming to this second. So second is placed at an angle of, okay, if we consider this to be 0, then this angle till second, that means this particular line. This line and this line. So it is 120 degrees. If we are measuring this one in this direction, that is the Cartesian coordinate system, so it becomes 120 degrees. So theta is 120. What will be r? R would be minus 120 degrees because it is negative of theta. What would be this direct? It would be 2 times of this direct for secondary. So it is 2 times theta. So 120 into 2, that would be 240. So it is 240. This would be minus 240 degrees because it is minus 2 times of this one. So how we got this angle 120? With respect to the first one, okay, what is the value of second? It is at 120 degrees. Okay, that would be direct. So theta, reverse would be minus theta, that is minus 120. Direct for secondary would be 240 and reverse for secondary would be minus 240. For third, again measuring with respect to angle with respect to engine 1. That is what I am writing here. First engine. So for third, if you see what would be the measure, this is 120 and again this is 120. So total between 1 to 3 would be 240 degrees. So this is 120, this is 120. Sorry, this one. Maybe I will erase it so it will become more clear. So this is 120 and again this is 120. So it would be total of 240. So theta is 240. Direct is theta 240, reverse would be minus, so minus 240 degrees. Then 2 times of 240, so it would be 480. So secondary, it is 480 for direct, and for reverse it would be minus 480. How we got it? So angle with respect to first, that is 240, so direct 240. Reverse is minus of theta, so theta is 240, so it is minus 240. Over here, 2 theta, that is direct is 480 and reverse is minus 480. So I hope like you got this table. Now we are going to use this table for constructing and finding the forces. So let's look at one. So now I will do some things over here. So maybe let me make this smaller, a bit smaller. Take a pencil. Now next step is draw circles. 1, 2, 3 and 4. Draw 4 circles. Why I am drawing 4 circles, I will explain it to you. This is for primary. This is for secondary. First one is for direct and second is for reverse crank. This is for direct and this would be for reverse. Okay, so we have four circles: primary, direct, secondary, direct, secondary, reverse. So we have these four circles. Now what we need to do with this four circle is mark the positions of the line of stroke. So this would be one position. Second is at 120, this position. So I mark this as over here. For third, I mark it over here. So this is number one, this is number one, this is number two, and this is number three. Similarly, you do this activity for remaining. 1, 2, 3. This is position of what? Position of the line of stroke on the. So you have drawn basically and put it over here. Now, if you see this omega is in which direction? This is in anticlockwise. For direct, what I say is this is in this direction. For reverse, if you view the previous lecture, for reverse, it reverses the direction. So this is the direction. So it is in clockwise sense, reverse would be in anticlockwise sense. For direct over here, it would be in clockwise sense. For reverse, it would be in anticlockwise sense. So we know the directions now. Okay. Where do we get the direction? You assume the direction it is in clockwise. The engine is rotating in clockwise sense. Now, next thing is putting the masses. So you got this diagram, the position of the engines from the line of stroke, the numbering 1, 2, and 3. So basically, maybe I can put it like this one if you want to make it like more visible kind of thing. So 1, 2, and 3. So it is 120 degrees for each. You can do this way also. So this is rotating in this direction for our convenience. This is rotating in the next direction. Why we require these directions, I will let you know within a minute. I made it in red, so let me make it in red. Okay, now moving to this diagram. This is very important step. Okay, at this position, okay, when the crank is at this particular position, the mass will be kept at this particular location. Where is that location? I said that this is at 0 degrees. I made this as a 0 degrees. So m by 2 is kept at what? At m by 2. If you see over here, so m by 2 for direct is kept at 0. 0 is which direction? Is along the crank. So the first mass, half of the mass of reciprocating is kept at over here. For reverse, it is again kept at 0. Where is 0? 0 is at this position. So m by 2 is kept over here. Next. So these two are done. Next, when this crank will rotate and come to position number 2, okay, that means ideally the mass should be placed at m by 2. But currently it is at location number, where is it located? It is at location number over here. So what I need to do is I need to take consideration of these particular angles. So ideally the m by 2 should be placed at this position. But since it is located on one single crank, what I need to do is I need to move the masses based on these particular angles or angles between the engines. Now how to do that? Okay, let's look at that. Ideally it should be kept over here, but it is located at what? It is located at 120 degrees. 120 degrees in which direction? In this direction. So what I do is like I keep the mass over here and move the mass about 120 degrees. So I move this mass by 120 degrees. So the angle between 2 and 1 is 120 degrees. So where the mass will be placed? The mass will be placed at location number 1. I will try to explain it again. Ideally the mass should be kept over here. But since it is rotating on single crank, the mass is not located over here, but we need to do it with respect to these angles. So how it is placed? So m by 2 kept over here and rotated at an angle of 120 degrees in which direction? In the direction of direct crank. So it moves out over here and it goes to m by 2 over here. So the mass is placed at m by 2. So this is done. Next, reverse is at minus 120 degrees. So the mass, where are we going to put this mass? So if you look at this one, ideally the mass should be kept out over here, but it is moving in this direction by how many degrees? By 120 degrees. So going out over here, this minus sign is just reflecting this directions. So minus should not come over here, but it should move with this direction. So it should be kept ideally at this position, but this 120, it has to move with 120. So it moves from this location 120. So 120 means this particular line. So it is placed at this particular location. Okay, I will explain it again. Okay, for point number 2, for direct, okay, ideally the mass of crank should be at this location, but since it's working on a single crank, it has to be rotated by some angle. That angle is given by this one, 120 degrees. So assuming that this is the direction, okay, the mass is kept at this one and located, and it is relocated with an angle of 120 degrees. So it moves to this newer position. So the mass is at m by 2, which is located over here. So this is for first engine, this is for second engine. For reverse, ideally it should be located over here, but since it is in this direction, we need to move it by an angle of 120 degrees. So in this direction, if we move it in 120 degrees, the mass gets displaced from point number 2 to point number 3 over here. So it is m by 2. So this is done. Moving to the next one, that is third one. Okay. Ideally, the mass should be located at this particular position. The mass should be located at this particular position. But because of a single crank, what I had explained earlier, it won't be kept over here. It would be moved to some other location. How it should be moved? It should be moved with this particular angle. So with 240 degrees. It is rotating in anti-clockwise sense. So this mass is moved from this location 120 plus 120 would be 240. So the mass would be kept at point number 1 over here. It should be kept at point number 1. So this is the location, original location, but it is moved by 240 as we have seen with this diagram. So the mass is kept for direct. So this is done. Coming to the reverse one, this minus sign is the direction of rotation. So ideally the mass should be kept at m by 2 mass should be kept at point number 3. But since we are rotating in this direction, so and working on the single crank, so it won't be located at this particular position, but at a 240 degrees angle. So if you move from over here, so it will move 120 plus 120 would be, so 120 would move me to this one. So the location of masses for these two diagrams, you got this one. Now once you look at this particular diagram, okay, the entire mass, the entire reciprocating mass is concentrated at point number 1 for primary direct. And in primary reverse, if you see, the mass m by 2 is kept at 1, the mass m by 2 is kept at 2, the mass m by 2 is kept at point number 3. So if you do the resolution of this one, it will come out to be 0. Okay. If you do the resolution, okay, resolution can be done in this way because this is m by 2 r into omega square. If you do a resolution of this one, if you do a resolution of this one, if you do a resolution of this one, okay, taking into consideration this m by 2 r omega square, and this is theta and cos theta. So what will happen is this 2 will balance out, this 2 will balance out, this 2 will balance out with this, and this will balance out, and it will be 0 Newton. I think you can do this exercise out over here by taking angles. You can find the angles over here. This is 120, so you can take an angle like what would be the resolution, you can take and try to do it. But what I'm interested is in, so for F primary direct, it is 0. Sorry, F primary reverse, it is 0 newtons. So that exercise you can do it out. Now, for this one, the entire mass is concentrated where? On one point, and that point will give me the entire mass. So it would be 3 by 2 times of m. M by 2 plus m by 2 plus m by 2. So 3 times m upon 2. So the entire mass is concentrated at point number 1. So the primary direct force would be 3 times of m, and it will be in radial direction. This will be in radial direction. So the magnitude of force out over here, Fp direct, will be 3 by 2 times m into r. This is the mass, the entire mass. This is located at point number 1. Point number 1. So mr into omega square. So 3 by 2 into m. What is value of m? M is 1.5291 into R. You know the R, value of R. What is value of R? R is 50 mm. So value of R is 50 mm. So 50 into 10 raised to minus 3 times of 3 into omega square. So what is the value of omega? It is 314.159 square. So once you multiply all these things, you will get the value of FPD, FP direct. It would be coming out to be, okay, I have that ready-made value, which I had already calculated. It comes out to be 11,318.69 Newton. And FP reverse, primary reverse is 0 Newton. So FP, that is primary, force primary would be 11318.69 Newton. So you got one of the answer. So you got this answer, this particular answer. So this was the activity that we performed for the primary one. Now let's tackle the same thing with this particular one. Now, whatever exercise we did for primary, we are going to do it for secondary. Now for secondary, let's draw this diagram, a bigger one, and then we can have it. So we have this, this is 1, this is 1, this is 2, this is 3. This is 1, this is 2, this is 3. This is for direct, this is for reverse, and we are looking this for secondary. Okay. So again, look at this one. Okay, I will just erase this particular thing. What we are assuming is like this is at 0 degrees. This vertical line is considered to be 0 degrees. Now look at the secondary one. So we need to look at this particular data. So when we look at this particular data, what we see is the mass. This is for the mass. Mass for direct secondary is kept at 0. 0 is this particular line. This particular line. This is 0 degrees. So m by 2 is kept out over here. Similarly, m by 2 for secondary direct and secondary reverse. This is for reverse. Both are kept at this particular locations, m by 2, m by 2. Next is for secondary direct, 240. Now ideally what I mentioned out over here is, ideally the mass should be kept out over here, because when this is in line with the cylinder, the mass should be kept out at this particular point. But since it is operating on the single crank, it won't lie over here. What will happen is like it will be moving with respect to certain angles and with respect to certain direction of rotations. So whatever direction of rotation we had considered in primary, we will consider the same directions for secondary. So we had considered for direct as clockwise and for reverse as anti-clockwise. So what I do is like, I ideally should keep the mass at point number 2, but it is relocated at 240 degrees with respect to 2. So where will it go? So it should move 240 degrees in this direction. So it will go 120. So this is the idle position. It moves till 120, from 120 till 240, this particular value. So it moves to this particular value, which is at 240 from crank number 2. Next, for reverse, okay, you see like minus is deciding this direction. So 240. So ideally, wherever it should be over here. But we need to move by how much? We need to move by how much? We need to move by 240. So if you see where it will go in either in this direction or this direction. So we will need to look at this direction. So we need to go by anti-clockwise. So ideally it should be at this position, but it has moved with 240. So 120, 120. So this goes 120 and 120. So this will be 240. So the mass would be located at point number 2. This is for engine number 1. This is for engine number 2. Second engine, I can write it over here so you can get it. This is for first engine. Next, coming to the third one, like, okay, for secondary direct, this is at 480. Ideally it should be kept at this position, but since we are operating with the same crank, it won't be located at this one. It will move with 480 degrees. 480 degrees is equal to what? 360 degrees plus 120 degrees. Why I made it 360 plus 120? Because this 360 will make a full circle, or it will come back to the same point. So if you look at this one, okay, ideally where it should be located at this point, but we need to go by this direction with 480. So this will move me to 360 plus 120. So it will be at this location. So 120 degrees. So 360 means from 3 it will come back to 3 and 120. So 480 degrees means it will go to this point number 2. So the mass will be kept at this location. Coming to the secondary one, this minus sign is given by this rotational angle. So where it will be located? Ideally it should locate at this point, but it will move 480 degrees. Again, that 480 means 360 plus 120. In which direction? In the direction of this particular thing. So it will go from this one, come to 360 plus, from here it will go and it will be 120 degrees. So the mass will be kept at this particular location. So it would be the entire mass that is concentrated at this particular point, point number 1. So if you see or compare with the primary one, you will see like the direct is becoming reverse in the secondary. Direct primary will become reverse in the secondary. And over here, primary reverse will become secondary. So automatically I can say, you can do that exercise. So force of secondary direct will become 0 Newton on resolution. And for reverse, we need to calculate that particular thing out over here. So how to calculate that one? Let's look at that particular thing. So we know F of secondary of reverse will be M into R. If you remember this one, we need to have this R, then ohm square. Okay, so you need to have this ohm square. So this mass, how much is the mass? So this will become 3m by 2, this mass, because the entire mass is this mass. R, what is the value of R? R is, can somebody tell me? Okay, so R is R by 4 times of n. And what is ohm? Ohm is 2 omega. So this is the value, this is the value. Just to have an analogy with this particular formula, we write this one. So total mass, what is the total mass? It is 3m by 2. What is R? R is R by 4 times of n into this is into 2 times of omega square. So if you substitute this one 3 by 2 m into r by 4 n into 4 times of omega square. So this 4 gets cancelled out. So it becomes 3 by 2 m r into omega square upon n. So FSR. This is secondary force for reverse. So if you see this one and substitute the values based on this particular data, okay, you will get the final answer. And the final answer is like the value of this will be equal to 3000. I have that calculated 3772.897 Newton. So this is the secondary reverse force and secondary direct is this one. So Fs would be Fsd plus Fsr. So Fs total would be 372.897 Newton. So this is the secondary, this is the primary. But for engine, the secondary and primary are meant for calculation, easy calculation. So total unbalance would be total Fs secondary plus F primary or F primary, whatever like you can write out. So it would be 11318.69 plus 372.897, which will be equal to 1500. So total unbalance in this engine would be 1509.587 Newton. So this is about solving the problem. So what you should always remember is, okay, from the word problem, draw the diagram, then write the given data. This is the important step number 1, finding the angles for direct and reverse for primary and direct and reverse for secondary. For that one, what you can use is this particular relation. Okay, for direct, primary it is theta, for reverse it is minus theta. For direct secondary it is 2 times theta, for reverse it would be minus 2 times of theta. So once you get these particular values, okay, start looking at this particular engine and see, okay, if I assume this as a reference line with 0 degrees, so it would be theta is 0, minus theta is 0, 2 times theta is 0, 0. Next is this one, this value is theta is for like 120 degrees, so 120 degrees. So automatically put the relation, get these values. Similarly for third one, get all the values. Next is decide the direction of rotations. So rotation is in anti-clockwise, rotation is in clockwise. So for this values like of angles, we need to use that particular thing. Draw a 4 circles. 2 circles are for primary and 2 are for secondary. Primary direct, primary reverse. Secondary direct, secondary reverse. Mark the line of strokes by 1, 2 and 3 over here. 1, 2 and 3, 1, 2 and 3, 1, 2 and 3. Now for masses, put the mass at that location, see the angle and see the direction of rotation and move the masses accordingly and keep it where it gets onto. You will see like for most of the cases what will happen is like for one point like all the masses will be concentrated and in another like you will get it dispersed. But in dispersed also you can do the resolution of forces and find the values. In this case it becomes 0 for primary reverse. For primary direct you got this value. And for primary, we know it's mr omega square. So putting that values and getting the answer. Secondary also do the same thing with these angles, find the values and get the secondary force. But since this is the same engine, so primary and secondary would be the total unbalanced force and get the values. So this suffixes the problem on radial engines. What you can do is you can practice more problems on this basis. If you have any questions, any doubts, any queries, ping me up in the section or you can call me up. I can help you out with that one. So thank you students. Thank you. I will stop the recording now.